Hello everyone, we are from SRF Limited, which is an Indian multinational having many businesses, and we are from packaging films business of SRF. Our project is conversion of non-usable metallized polyester film waste into raw material by unique demetallization and recycling process. My name is Manoj, and with me are my friends and colleagues BN, Sachin, Ramesh and Parikshit, sponsored by my boss Mr. Harikishore Singh and facilitated by my guru Mr. J. Ravikant. And what we're doing here is, since this is an exploratory kind of project, research-based project, so we are using a task-achieving type 8-step SRF's proactive problem-solving methodology here. So where this need is coming from? This need is coming from FMCGs or brand owners looking at sustainable partners, SRF wanting to be a responsible corporate supplier to them, and there was global industry transition happening towards sustainability. There were foundations like Ellen MacArthur Foundation, where a lot of brand owners took oath of working towards sustainability within a given time frame, which led us to take a policy goal in 2019 about enhanced effort towards sustainability, under which 5 themes were identified. While there were other teams who took up projects like single family structures, product portfolio shifting from packaging to industrial, we as a team thought of taking 3R as a challenge, and under which we chose conversion of non-usable metallized polyester film waste into recyclable and reusable polymer. So if you see the life cycle of the metallized film, see, we are producing 2 types of films. One is the transparent films or the bare films, which constitute about 76% of total production, and the waste of this particular stream goes back into the same process, and this is continuously being used. And there is another stream which is like metallized films, which corresponds to 24% of the total production. Metallized films are used for improving the barrier properties of the food or the non-food package, while the A grade goes to the customer. There's a 2.5% wastage gets generated during the process, which corresponds to 535 tons per annum. And this finds use in paper plate or rope manufacturing, and finally finding end of life cycle in the landfill. So what we thought that we want to eliminate the sale of this 535 tons of wastage. So these are the 2 types of waste that we produce. One is in the sheet form, other is in the trim form. And the challenge in front of us was, how do we achieve complete removal of aluminium from this film, and how do we scale it up, as there was no known technology which was available. So what we wanted to do, we wanted to have a non-hazardous, easy to use process for complete demetallization of this metallized film waste. And fortunately, since we had already the transparent film waste with us, so identifying target Q was not a challenge for us. So we identified target Q in terms of the ash content, moisture and contamination, similar to the transparent fluff. Target C, what we thought that the cost of conversion should not make this fluff more costlier than the raw material cost, so that is our target C. And target D, since I said 535 tons per annum corresponds to 45 tons per month, so that is our target D. And with respect to the timelines, since this was an exploratory type of project, as I already said, so it required lab work, and using adjacencies of the BOPET film knowledge and internal capabilities, we wanted to understand as to how we can extrapolate this to handle low bulk density materials. So what we did was, using PDPC, we took trials with various solvents in various concentrations at various temperatures, with agitation, without agitation, using PDPC, and finally ended up finding an alkaline solution which gave us complete demetallization. And the residual water was again a challenge for us to neutralize this. So we extended this PDPC to find a best fit acid which could completely neutralize this residual water to be used safer in the effluent treatment plant, and finally back into the process. So the next big challenge in front of us was, how do we scale it up? So we know by virtue of being in the polyester industry that there are PET bottle crush wash lines which are available. So we chose 2 suppliers based on our evaluation criteria, persuaded them to partner with us. One of them agreed to build a 10 kg per hour prototype for us, and we sent our waste to his site. We took trials as it is without any modification to the PET bottle crush wash line. So what we found was there were metal traces, which meant there was incomplete demetallization. The fluff was not moving forward as a continuous process, and there was very high moisture, which led us to do a design FMEA where we had to increase the surface area for complete demetallization. We needed to change the agitator and the conveyor for fluff forward movement, and we had to increase the dryer length to have it moisture-free fluff. So once this fluff was achieved, we brought it back to SRF, since ultimate objective was to use it as a raw material. So we brought it back into the main extrusion line, we injected it back, and we took 4 sequential trials. While the processability was good in terms of the film breaks, there was slightly grayishness in the color which needed further redressal while we order this on a full-fledged basis. So we ordered this complete equipment to this particular vendor, which took about 6 to 8 months. Our job was, meanwhile, to find a best fit layout. So we did many iterations. We used vertical space in terms of shifting some cooling towers vertically up, and the shredder needed to be located very close to where we were storing the waste, and we finally ended up saving about 50% of the space that the vendor proposed to us. And when the equipment reached us, we carried out a process FMEA since we envisaged certain problems during the pilot scale. So we thought of doing FMEA here again. So we envisaged that there will be high fines in the drain water, there will be choking of the cutter, there will be there might be metal accumulation along the floater, and again the high moisture. So the countermeasures were identified and implemented, and we finally commissioned this plant in July 2020. Time for verification now. So we verified both in terms of the recycled chips quality and also the film quality. Talking of recycled chips quality, the intrinsic viscosity is pretty stable, well within the range, and also the ash content. The tensile strength being the most critical characteristics of the films. We verified this. The process here again is very stable with a CPK of 1.44. So all CTQs are meeting the requirements. So what we thought was that we must do a GPC analysis of this. So we checked the molecular weight before and after, which was found well within the range. We sent this sample for food compliance certification outside. So before and after, the film was found food compliant. Coming to the verification of the larger goal, as we said initially that we don't want to sell this waste anymore, and we are happy to share that from October 2020 onwards, we are not selling this waste outside, except for these 2-3 months of March and April where there was COVID and we had to shut down the plant for want of labor. So we are happy that we have completely eliminated the sale of this non-recyclable waste. Coming to the IO ratio improvement, so we have been able to improve the IO ratio by 61.5% by virtue of recycling this waste back into the polymer stream, and in addition to which we have been able to save on the carbon footprint to the extent of 920 odd tons per annum. This whole project included 63 different activities which we were able to complete within more or less within the given time frame. This required 25 odd people at the project stage, and for the routine operations we need about 10 people to run this plant. This whole project costed about $330,000, and we are, although we said that the cost should not be more than the raw material cost, but we are very happy to share that this project has actually given us an ROI of 70%. Since this was a new project, this required establishment of new standards, which we did, including SOPs, WIs, maintenance checklist, including the revision of the QCPC, since this whole fluff wanted re-injection into the main lines. So the mainline QCPC needed revision. There are some things still under process like automation of feeding and chemical dosing, which we are doing. Coming to the reflection, so what we feel that goal 12 and goal 9 are the best suited goals met during execution of this project. Goal 12, why? Because this is responsible consumption. As we said, we have actually been able to recycle 535 tons of waste back into the raw material stream. So that is a responsible consumption for us. Goal 9, quite innovation. This is quite an innovative project because no one has ever done it earlier. We are the first one to do this, and we are very happy to share that 2 of our competitors have already ordered this same line to the same vendor. And since we have plants in Thailand, South Africa, Hungary, there are horizontal deployment opportunities existing. So we have already started executing this plant at PFB Thailand plant, and going forward we'll be doing in South Africa and Hungary. And whenever there's any customer or FMCGs visiting us, we proudly share our success story with them, and they feel proud that they are associated with SRF as a responsible and innovative partner. And we are happy that we have been actually able to improve or increase the end of life cycle of the polymer to support circular economy, which according to us is when a stream of waste goes back into the process for the same product, that is circular economy to us. And we are happy that we have been able to achieve, which has led to our capability development on our journey to sustainability. This is a small video that we want to show you. about how the process goes. This is the material feeding into the shredder. The shredded waste goes into the alkaline solution for washing, and finally transported to the acid wash tank for neutralization, conveying to the water wash to remove any residual acid. Second water wash, finally to the dryer for moisture removal, and conveying to the existing recycling system. So as SRF logo says, we always find a better way, and we are very happy to share that we have actually found a better way yet again. Thank you so much.